All right, we're going to do lesson 3.5 today, and we're sticking with our exponential functions and our logarithmic functions, and we're going to do some solving equations. Solving. All right, so we have two types of equations to solve. We're going to do exponential and logarithmic. Bless you. I have about 5 examples each. Hopefully it won't take too long. Now, here's the key thing in solving, though. All right, part A, exponential. Expo equations. You have to write down the equation, and you have to show work. I know that's really hard for some of you, and you can do them in your head and blah, 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 but no. You have to write them down. And not only that, but you need to solve equations mathematically going down the page. Okay, I still have people that, maybe not in here so much in Algebra 2, they solve it across the page like they're writing a sentence. It's really weird, bless you. You work down the page. You used to do that? Oh, no. Yeah, you do that. You're not supposed to. Because it's all done, like math's different. Math goes down your page like that. You just do your steps after another like that. Yeah. All right, and sometimes if you want to, if you have a lot of equations to solve, you can draw a dotted line and do like half of them on this side, half of them here, because you're working in columns instead of across. All right, so let's start with exponential equations. You want to isolate the exponent and then take the log of both sides. That's pretty much what you do. You did these in Algebra 2. They're a little bit harder here. So let's go ahead. I'm just going to start you out with one. You have 4e to the 2x equals 5. Okay, so we're trying to find out what x is, right? You can use guess and check all you want if you want to, and that's not a really great way to solve it. But we're going to solve these algebraically. We're not doing these graphically either. We're not setting that y1, that y2, and find the intersection. That would work, but we're going to solve these algebraically. So the first thing we're going to do is we're going to divide by 4, because we want to isolate this e to the 2x. So divide both sides by 4, and you get e to the 2x equals 5 over 4. All right, then you want to take the log of both sides. You could take the log of any base you want to. It doesn't matter. If my base is e here, I'll take the natural log of both sides. Okay? It just works out much better that way. So I'm going to take the natural log of e to the 2x equals the natural log of 5/4. Now, here comes that favorite property of mine, the one that says you can take that exponent and move it down to the front. And you get 2x times the natural log of e equals the natural log of 5/4. All right, so there he is. You see Lenny? He's so cute. He's just 1. Lenny's 1. He's just a little baby. So you get 2x times 1. 2x equals the natural log of 5/4. And then to solve for x, last step, divide by 2. And we're going to round to, I think, 3 decimal places, is what they say. So x would be approximately, and you'll need your calculators. Some people like the answer left like that, natural log of 5/4 over 2. I don't know, it just depends. The book likes to do it in a decimal. So you would do natural log of 5 over 4. Make sure you close the parentheses. I like to hit enter just because I'm a little scared that it's going to do it in weird order, and then divide by 2. It would probably work out, but I just get a little scared. All right, so it would be 0.112, and that would be your answer. So when you're solving, I want you to write the problem down, show work, and you don't have to show I show all the steps just so that you don't get lost. So I had a college professor that wouldn't show hardly any steps and just think that we all knew where he went, and I was like, where did you go? And then I'd ask, and he'd get all mad, you know? But I'd still ask, though. Yeah. So I'm like, how'd you get from that step to that step? And he'd like treat me like I'm an idiot. But I can't read his mind. So I like to show all my steps. If you like skip a step here or there because you do it in your head, that's okay. But I want you, for the most part, show your work, okay? All right, number 2. Here we go. That was the easy one. Let's do some harder ones. Number 2, let's do, that one's pretty good. 20 equals 10 times 1.06 to the x power. Okay, this you might kind of recognize, yeah? Do you remember this? Kind of like you start with 10 grams of whatever, and they're growing at a rate of 6%, and you want to find out when there's 20, okay? Well, we're going to do this algebraically now instead of graphically. So the first thing we're going to do is we're going to divide both sides by 10. So 2 equals 1.06 to the x power. Now here's where you can take the log of both sides, and you can take any log you want. I usually just do just the common log, just base 10. You could do natural log, both sides, it doesn't matter. So I'm just going to take the regular base 10 log. So log 2 equals log 1.06. I'm going to take that x at this part, move it to the front. Okay? That's why you take the log of both sides, so that you can move that exponent down. And then finally, divide both sides by log 1.06. So log 2 divided by log 1.06. Go to your calculator. And this was all done, you know, graphically the other day. Some of you guys were solving it like this because you remembered from Algebra 2.06. And you get about 11.896. So almost 12 years if it was, you know, a word problem type of thing. All right, now we're going to do one you haven't done before. So you've done all these. You're probably bored to death right now. So you want a challenge? Here it comes, number 3. E to the 2x minus 3e to the x plus 2 equals 0. Okay. We're solving for x, and the problem is there's an x here and there's an x there, and that's really strange, okay? But if I look at this, this is a trinomial, right? It's got 3 terms. What do we do with trinomials? We factor them. We're going to factor this. Yeah. Does that even look factorable to you? No, right? Okay, we're going to factor this. It is factorable. I'll show you. To get e to the 2x, that would be e to the x times e to the x. Right? When you do e to the x times e to the x, you add the x's. X plus x is 2x. And then you go, what times what's 2 adds up to negative 3 in the middle would be a perfect negative 2 and negative 1. And if you're like, where did that negative 3 e to the x come from? That's the OI part. Negative e to the x, negative 2 e to the x gives us negative 3 e to the x. So it's factorable. Weird, huh? Okay, now that you have factors and they're equal to 0, you just set each of your factors equal to 0 and solve them. Like that. Okay? So add 2. E to the x equals 2. Take the natural log. When you take the natural log of e to the x, you just get x. X equals natural log of 2. I really like that answer. You can write 0.693 if you want to, but that's nice, pretty. Over here, add 1 to the other side. Take the natural log. So you get x equals the natural log of 1. What is the natural log of 1? 0. Yes, thank you. It is. And you get 2 answers for that one. You haven't done one of those before. But those are fun, right? Did you like it? No? Okay, great. All right, let me see. What else? Oh, this one's so good. This one's interesting. Number 4. Here we go. This one you haven't done either, but it's the same idea. So, all right, suppose you have 27 to the negative 2x plus 6 equals 1/9 to the 5x. Oof. No, Sam? Sam's saying no. He shook his head. Okay, for this one, it's a little strange. We're going to start by taking the log of both sides, okay, because there's nothing we can do. There's no trying to get something to the other side. Now, like I said, you can take the log of any number, any base, okay? You can do log base 10 on both sides. You can do natural log. You know what I'm going to do here? I'm going to do log base 3. You think I'm crazy? No? Okay. Let's do log base 3, 27 to the negative 2x plus 6 equals log base 3 of 1/9 to the 5x. Okay. Yeah?
Would it help at all if, like,
You could totally do that. Like this would be 3 cubed. Is that what you're saying? And that's 3 to the negative 2. You could do it that way. Yeah, so I'm going to bring the negative 2x plus 6 down, and then I'm going to evaluate log 27 base 3. What is log 27 base 3? 3. That's why I took log base 3. And it worked out really nice on this side too. I take the 5x down, and what is log of 1/9 base 3? It's negative 2. But I like how you said that, because you would have put that to the top and that would have come down. It would have been the same exact thing. Yeah. Okay, so we get over here. Now the rest of it's just algebra, right? It's just basic solving. So you get negative 6x plus 18 equals negative 10x. You could add the 6x over. 18 equals negative 4x. So x would be negative 18 over 4, which is negative 4.5 or negative 9/2. And that would be a really good problem to put on a non-calculator section. Yeah, because you know, we didn't use our calculator at all. If you take log 10 of both sides and you're doing log base 10 of 27, you don't know that. You can't do that without a calculator. So that would be a really good non-calculator problem. All right, so that's exponentials. Let's go to logs now. Part B. Only 2 parts today. You're going to get a lot of time in class today. I knew that. I thought you might need it today. I don't know. I kind of need it. Parent-teacher conferences were awesome. They went long, though. I didn't get home till like almost 7. It was late. All right, we're going to do some log equations now. Those of you who are in sports, you're like, I get home later than that every night. Seriously. All right, I have 1, 2, 3, 4, 5, I think. All right, so let's go ahead. Log equations are hard for people. They're harder than exponential because with log equations, you don't do something to both sides, okay? What you do is you take a log and you rewrite it in its exponential form. With every single equation you've ever solved, you pretty much do to one side as you do to the other, and you like add this to both sides, or you subtract, or you take the square root of both sides. With logs, you don't do that, and that's why they're harder for people to do. All right, so here we go. Let's do it. Number 5. I'm going to start you off with a pretty easy one. Let's say that we have log of x base 4 is equal to 0.7. And we have to find out what x is, okay? Now, some people want to divide by log 4. That doesn't make any sense. Or multiply both sides by 4. That doesn't make any sense either. What we're going to do is we're going to rewrite this in its exponential form, okay? So the base is 4. The exponent is 0.7. And it equals that. Isn't that what a log is? Base to the exponent equals whatever's inside. So it's 4 to the 0.7 equals x. And then you go to your calculator, and you figure out that 4 to the 0.7 is 2.639. And that's it. Okay? But that's hard. People get stuck right there. Like, how do I get rid of this log? You get rid of the log by rewriting it in its exponential form. When I ask you, you don't need to write this down, but when I ask you, what is log 8 base 2? How do you get rid of that log? Well, you really kind of do this. You make an equation for yourself. You're saying 2 to the what equals 8. You get rid of the log by writing it in its exponential form. That's what we just did. Okay, number 6. Oh, this one, yes. All right, log of 5x minus 1 base 3, always love these, equals log of x plus 7 base 3. All right. It's funny how something like this will bother people. Like, there's logs on both sides. What in the world? What am I going to do? Just stand back and kind of look at it, right? If you have log base 3 of stuff, and you have log base 3 of stuff, then mathematically speaking, stuffs have to be equal, right? Yeah. The stuffs are equal. I love that. So 5x minus 1 has to equal x plus 7. I mean, it's really that basic. And then you solve. So subtract x, add 1, x would be 2. And you're like, whoa, that was an easy one. But sometimes those easy ones, you start, okay, what do I do to both sides? And you start over-analyzing it. Number 7. Here we go. Let's see, I think I might take one off of here. There's a lot of good problems over here. Yeah. Okay, let's do log of x base 3 plus log of x minus 8 base 3 equals 2. Whoa. Okay, this is not stuffs equals stuffs. This is a little bit different. This is what we want to do is we want to get all of our logs into one single log, okay? They're both base 3, so let's combine them using our log properties that we learned yesterday. So we get log of x times x minus 8. Remember, plus means multiply. And this is equal to 2. All right, now we're going to rewrite this in its exponential form. So we're going to take 3 as the base to the exponent equals. And I always draw these arrows because I think they help. Bless you. I don't know if they do or not, but they've always helped me. So I'm going to write 3 squared equals x times x minus 8. Okay, so 3 squared is 9. And this you distribute. And now we have a quadratic to solve. But you know me, I like to make my quadratics factorable so we don't have to use the quadratic formula. So let's go ahead and subtract 9 to the other side. So x squared minus 8x minus 9 equals 0. And then we'll factor x and x. What times what's negative 9 adds up to negative 8? Yes. Remember when you weren't good at those? Like when you first learned how to do them, it was like, and now they're just easier. All right, so x is 9 or negative 1. Now the thing with exponential functions is their domain's not all real numbers, right? Like if I said over here, y equals log of x. X would have to be greater than 0 if I'm going to evaluate the log of it, okay? So if we look back, yeah?
Isn't it negative 9 positive 1?
Yes, when you factor it, it's negative 9 and positive 1,
Oh, sorry.
and then you solve. Yeah, you're right. Okay, so then you go back to the very original problem right here. This original problem, you have to check for extraneous solutions. You know, you're probably like wondering, when do we need to check for extraneous, when do we not? You have to check whenever the domain is not all real numbers. Radicals, domain's not all real numbers, you have to check those. Rational functions, the domain's not all real numbers. Log, domain is not all real numbers, okay? So you have to go back and check, and guess what? One of them doesn't work. Which one? Negative 1. Cross that one out. Your only answer is x equals 9. So good, huh? You love it. All right. Let's do, got another one for you. Number 8. Have you had enough? Never. You've never had enough. I don't like that one. Sorry, I'm kind of pulling them from something that I saw online that I really liked some of these. Okay, let's just do one more then. One more. This one. Natural log of x minus 2 plus the natural log of 2x minus 3 equals the 2 times the natural log of x. All right, so I've got natural logs on both sides. Let's go ahead and use our properties to get each of these looking a little bit better. So let's take this. This would be the natural log of x minus 2 times 2x minus 3. Okay? And this one over here is the natural log of x. We're going to take that 2 and we're going to move it that way this time. So we get the natural log of x squared. Okay, remember stuffs equals stuffs? Same thing here. We have the natural log of this stuff equals the natural log of that stuff. So those have to be equal to each other. So let's FOIL this out. We get 2x squared minus 3x minus 4x plus 6 equals x squared. Okay, we're solving a quadratic, so let's bring everything over to one side and simplify everything. So I have x squared minus 7x plus 6 equals 0. Once again, you know, I made this into a really nice problem, or I found it. If it's not factorable, you would have to do quadratic formula. Sometimes the book does that to you. I probably won't, though. And then you get what times what? 6 adds up to -7 would be a perfect. All right, so it's just like the last problem. You get 2 answers, and you have to check. Check for extraneous solutions. Just because that was a negative on that last one doesn't mean that it's extraneous. If you plug it in and it becomes negative, you're taking the log of a negative, then it doesn't work. So 6, I would check in here. X minus 2, that would be 4. 2x minus 3 is whatever, but it's positive, and that's positive too. But 1, ooh, 1, I don't know, let's see. Aha, right here. When I plug 1 in, I get the natural log of -1. I'm not allowed to do that. So my answer would just be x equals 6.